Right now, beneath thousands of meters of cold, silent ocean, a machine the size of a skyscraper is moving completely unseen. No sunlight, no sonar ping, no trace it was ever there. Inside it, over 150 people are living in a steel tube, breathing recycled air, eating recycled water, and navigating a world they'll never actually see for months. And here's the terrifying part. With one order, this submarine can unleash more destructive power than every weapon fired in World War II combined. This isn't science fiction. This is the nuclear submarine, humanity's ultimate hidden weapon. Today, we dive in deep into the steel titan that can vanish for months and emerge with enough firepower to end civilizations. A nuclear submarine isn't just another boat. It's a self-contained fortress that operates in complete isolation from the outside world, unlike diesel-electric submarines that must surface every few days to recharge batteries and take in fresh air. Nuclear submarines are powered by onboard nuclear reactors that generate virtually unlimited energy. These vessels can carry nuclear fuel sufficient for approximately 30 years of operation, meaning the reactor itself rarely limits their missions. The power plant creates enough electricity to run every system on board, from propulsion to life support, without ever needing to surface for air. There are two main types: ballistic missile submarines, designated SSBNs, which carry nuclear-armed missiles, and attack submarines, or SSNs, designed for combat operations. Both share the same revolutionary capability. They can disappear into the depths and stay there longer than any other military platform in history. So how does a submarine stay submerged for months at a time? The answer lies in its nuclear reactor and advanced life support systems. Modern nuclear submarines can remain underwater for up to 120 days, approximately 4 months. The nuclear reactor generates heat through atomic fission, which produces steam to drive turbines connected to the propellers. This same power source runs the entire submarine, including critical life support equipment. The submarine takes abundant seawater and uses electricity through water to break it down into hydrogen and oxygen. The oxygen is released into the submarine for the crew to breathe, while the hydrogen is safely vented. A distillation plant simultaneously desalinates seawater by heating it to separate salt from water vapor, then cooling the vapor to collect fresh water. This distillation process can produce as much as 40,000 gallons of fresh water daily, used for cooling electronics, drinking, cooking, and personal hygiene. But there's one resource: nuclear reactors can't create food. According to research from Stanford University's nuclear propulsion studies, feeding roughly 130 submariners for 120 days requires storing 15,000 pounds of food, about 160 pounds per sailor. This means every square foot of available space becomes a storage area. Crews often walk on cases of canned goods stacked in hallways until enough is consumed to clear the floors. When submarines do need resupply during extended missions, they perform what is called vertical replenishment surfacing briefly. At night, while helicopters drop supplies that are loaded through missile tubes or hatches, stealth is what makes nuclear submarines so deadly. Their entire design revolves around one principle: remain undetected. The primary threat to submarines is sonar sound navigation and ranging. Active sonar sends out sound waves that bounce off objects and return as echoes, revealing a submarine's location. Passive sonar simply listens for sounds a submarine makes. To counter these threats, nuclear submarines employ multiple stealth technologies. First, anechoic tiles cover the outer hull, absorbing incoming sound waves instead of reflecting them back to enemy sonar operators. These rubber or synthetic polymer tiles feature complex patterns that scatter any inadvertently reflected sound, making the submarine nearly invisible to sonar detection. Second, nuclear propulsion itself is quieter than diesel engine. The reactor produces no combustion noise, and modern designs mount machinery on sound dampening systems to prevent vibrations from traveling through the hole into the water. Naval engineers focus on suppressing sound waves submarines generate, rendering their movements nearly silent, especially at slow speeds. When a submarine enters silent running mode, non-essential systems shut down. Crew members are urged to rest and avoid making unnecessary sound, and speed is greatly reduced to minimize propeller noise. But detection technology is evolving. Recent developments in magnetic anomaly detection, or MAD, allow sensors to detect disturbances in Earth's magnetic field caused by a submarine's metal hull. Meanwhile, LiDAR light detection and ranging systems can now track submarines by detecting their disturbance of the ocean surface or directly imaging them at depths up to 200 meters. Some experts project this could extend to 500 meters in the near future, though these technologies still face significant limitations in deep ocean environments. Nuclear submarines carry some of the most devastating weapons ever created. Ballistic missile submarines can fire missiles thousands of kilometers from their targets, and acoustic quieting makes them difficult to detect, making them a survivable deterrent in the event of a first strike. The United States Ohio-class submarines represent the pinnacle of this capability. Each SSBN is armed with up to 20 Trident to submarine-launched ballistic missiles, or SL. Each Trident II missile can carry multiple independently targetable reentry vehicles. A single missile can strike several different targets with separate nuclear warheads. Modern SLBMs have ranges exceeding 7,000 kilometers with precision comparable to land-based IC, traveling at speeds in excess of Mach 20. They can be launched from underwater virtually anywhere in the world as oceans, and they're incredibly difficult to intercept once airborne. Attack submarines carry different armaments. Virginia-class SSNs are equipped with Tomahawk cruise missiles capable of striking targets over 1,000 miles away. Mk-48 ADCAP torpedoes for engaging surface ships and other submarines. The UK's Astute-class submarines carry both Tomahawk missiles and Spearfish heavyweight torpedoes with a range of 44 miles. What makes submarine-launched weapons so terrifying is their strategic purpose. The SLBM ensures that a nuclear-armed state retains the ability to launch a second strike, or retaliatory strike, after absorbing a first strike that may disable land-based and air-based nuclear options. This creates what military strategists call mutually assured destruction, knowing that even a successful surprise attack will not prevent devastating retaliation. Nuclear submarine technology is extremely expensive and complex. Today, 6 countries deploy nuclear-powered strategic submarines: the United States, Russia, the United Kingdom, France, China, and India. The United States operates the world's largest nuclear submarine fleet. The U.S. Navy possesses as many as 71 nuclear submarines, including Ohio-class ballistic missile submarines, Virginia-class attack submarines, and older Los Angeles and Seawolf-class boats. The sheer scale of America's undersea fleet gives it unmatched global reach. Russia maintains approximately 30 nuclear submarines, a mix of attack and ballistic missile types. Its Baray-class SSBNs carry Balava, submarine-launched ballistic missiles with ranges exceeding 6,200 miles. And each missile can deploy multiple independently targetable warheads. China operates nearly 12 nuclear-powered submarines, split between attack and ballistic missile types, with its main goal being to strengthen its position in the Indo-Pacific and boost nuclear deterrence. The United Kingdom fields for Vanguard-class ballistic missile submarines its sole nuclear deterrent, along with several Astute-class attack submarines. France operates for Triomphe-class SSBNs and multiple attack submarines, maintaining an independent nuclear strike capability. India is the newest member of this exclusive club, with 2 Arahant-class ballistic missile submarines, currently in service and plans to expand its fleet. Several other nations are developing nuclear submarine programs. Brazil began construction on its first nuclear-powered attack submarine in 2080, while Australia is working with the United States and United Kingdom under the AUKUS partnership to acquire nuclear-powered submarines by the early 2040s. Nuclear submarines represent the ultimate strategic weapon because they're nearly impossible to find and nearly impossible to stop. These vessels can hide from reconnaissance satellites and fire their nuclear weapons with virtual impunity. Unlike land-based missile silos that have fixed locations or bombers that can be tracked by radar, a ballistic missile submarine on patrol could be anywhere in millions of square miles of ocean. Finding one specific submarine in the vastness of the world SCS is exponentially harder than finding a needle in a haystack. This survivability is their strategic value. A nation's ballistic missile submarines ensure that even if all its land-based nuclear forces are destroyed in a surprise attack, it still possesses the ability to retaliate with devastating force. This guarantee of second strike capability prevents nuclear war by making first strikes suicidal, but that same capability is why they're so feared. A single Ohio-class submarine carries more destructive power than was used in all of World War II. 70% of nuclear warheads in the USA are carried by ballistic missile submarines, making them the cornerstone of American nuclear deterrence. The psychological impact cannot be overstated. Somewhere, right now, multiple submarines from multiple nations are silently patrolling the depths, their crews standing watch over weapons that could reshape the world. They could be beneath shipping lanes, near or in the middle of remote ocean expanses, and no one knows for certain where they are. As detection technology advances with artificial intelligence, quantum sensors, and distributed sensor networks, some defense analysts predict the era of submarine stealth may eventually end, but for now, nuclear submarines remain the most survivable and feared weapon platforms ever created, silent guardians of nuclear peace, or harbingers of unimaginable destruction, depending on your perspective. The submarine that can stay underwater for months isn't just an engineering marvel, it's the weapon that changed the calculus of war itself. And somewhere beneath the waves, they're watching, waiting, hidden in plain sight within the endless blue.